Hello everyone, it's me Sanjay Vasu back again with another video for Maths Cambridge International Examinations Secondary 1 Checkpoint. Here is paper 1 of October 2016 for 1 hour. We are not allowed to use calculator for this paper. So let's start. Question 1. Here's a formula. Use this to calculate y when x equals 30 and x when y equals 56. Let's see the a part. So when x equals 30, then y equals 8 multiplied by 30, which is equal to 240. So that's the value of y. B. X when y equals 56. So 56 equals 8x. So then x equals 56 by 8, which is equal to 7. So that's the answer. 2. Draw a line to match each description to one shape. The first has been done for you. So the example is 1 reflex angle and 4 sides, quadrilateral. Next, 2 equal sides and 1 unequal side. So 2 sides plus 1 side, that'll be equal to 3 sides. So it's a triangle. And then 2 equal sides are there. So it's an isosceles triangle. Next, 4 equal angles. In that, we can say a square or a rectangle. Over here, it's a rectangle. So now 5 angles. So a shape which has 5 sides also has 5 angles, which means a pentagon. 6 sides is obviously a hexagon. Question 3. The sum of 3 numbers on each side of the triangle equals 100. Use the numbers 50, 59, 26, 24, and 15 to complete the diagram. Write one number in each box. So let's solve for this side. And because 35 is already given, we can say that the other two numbers sum, which are in these two boxes, will be equal to 100 minus 35, which is 65. There are two numbers which fulfill this, 50 and 15. So let's write them down. Next, let's solve for this side. If the total side sum is 100, and we already have a number 50 over there, then the sum of these two boxes will be 100 minus 50, which is 50. There's only one pair of numbers which fulfills that, and that will be 26 and 24. So now just one thing we need to note. Which number do we keep in this box? Because it needs to correspond with this. So when 26 and 24 are taken out, 59, which is the last number, has to be there. So now 15 plus 59 plus 24 will be equal to 98, but we need to have it as 100. Therefore, we need to take this out, switch their positions. Now if we add the three numbers in this row, we will get 100. So we have solved the triangle. 4. A. Complete these calculations. 0.64 into dash equals 640. So to find this number, we need to divide 640 by 0.64, which will be 1000. The second one is 6400 divided by dash equals 64. This is quite straightforward. So it is 100 here. Dash multiplied by 100 equals 6.4. So let's solve for the dash. That will be 6.4 divided by 100, which will be 0.064. B. Write down in words the value of the digit 4 in each of these numbers. The first has been done for you. So the number is 249.6, and the value of digit 4 is 4/10. The next one is 0.487. In this, the 4 is over here, which is the tenths place. So 4/10. Next, 0.0248. The 4 is over here, which is the thousandths place. So 4 thousandths. Question 5. The grid shows the positions of 3 points A, B, and C. Write down the coordinates of C. So let's look at the graph over here. Where's the point C? Right there. So where's the x coordinate? It goes down this line, so the x coordinate is 1. Then the y coordinate, it goes down that line, so it's minus 3. So the answer is 1, minus 3. B. ABCD is a rhombus. Plot the position of point D on the grid. So first let's connect the points A and C. This will be our center line. Now let's connect points A and B, and then points B and C. So this is half of the rhombus. Now let's look at point B. It is 2 away from the center line. So for point D, we need to make it 2 away from the center line in the opposite direction, which in this case is left, and it should be in the same y coordinate. So it'll be over here at -1, 1. So now let's make this point as D. Let's connect the points now, A and D, D and C. So this makes a perfect rhombus. So this is point D. Question 6. Complete these statements. A. 35% of 60, that'll be equal to 35 by 100 multiplied by 60, can cancel out a 0. This will be 7 and this will become 2. You can cancel out this and this. So that'll be equal to 21. B. 25% of dash equals 20. So 25% of, let's make this as x, equals 20. 25% equals 1 by 4. So 1 by 4x equals 20. You can bring the 4 to the other side, and then x equals 20 multiplied by 4, which is equal to 80. So that is the answer. X equals 80. Question 7. Bobby scores M marks in the test. A. Dan scores 2 marks less than Bobby. Write down an expression for Dan's mark in terms of M. So if Dan scores 2 marks less than Bobby, it'll be 2 marks less than M. That'll be M minus 2. That's the expression. B. Georgia scores 3 times as many marks as Bobby. Write down an expression for Georgia's mark in terms of M. So 3 times as many marks as Bobby means 3 times as much as M. That'll be 3M. 8. A. A bottle contains 250 milliliters of lemonade. Work out how many liters of lemonade there are in 6 of these bottles. First, let's see how many milliliters are there in 6 of the bottles. So 6 bottles will be 6 multiplied by 250, which is equal to 1500 milliliters. Now how many liters? So 1500 milliliters. Divide that by 1000, so 1.5 liters. That's the answer. B. Jenny has a suitcase with a mass of 18.1 kg and a handbag with a mass of 800 grams. Work out the total mass of Jenny's suitcase and handbag in kilograms. To do this, we first convert 800 grams into kilograms. So that'll be 800 divided by 1000, which is equal to 0.8 kilograms. So let's add that with 18.1. That'll be 18.9 kilograms. That's the answer. 9. Work out the lowest common multiple of 6 and 10. So we can use a method of simplification. Let's write the numbers 6 and 10 here. So we can write a prime factor of these numbers. That'll be 2. Now divide both the numbers by 2, 3, 5. Are there any more common prime factors for these numbers? No. Therefore, we multiply 2 multiplied by 3 multiplied by 5. So 2 into 3 into 5 equals 30. That is the LCM of 6 and 10. 10. The diagram shows the net of a cuboid. The areas of some of its faces are shown. So we have 3 faces which are having the area shown. 24 centimeters squared, 12 centimeters squared, 32 centimeters squared. The side lengths of the cuboid are all whole numbers. Complete the diagram to show the missing side lengths of the cuboid and the areas of the other faces. So first let's take these 2 areas of cuboid faces. Both of these have the same length over here. So these 2 will be in proportion. Because 8 is the highest common factor of 24 and 32, we can take that side length as 8 centimeters. Now, if we have that as 8 centimeters, this side will be 24 divided by 8, which is equal to 3 centimeters. And then, if we have 8 as this side, then this side will be equal to 32 divided by 8, which is equal to 4 centimeters. So we've solved the side lengths. Now we can solve the areas. In a cuboid, opposite faces are equal. So now let's visualize folding this cuboid. So if you fold the cuboid, these 2 faces will be opposite, and therefore the area of this one will be 12 centimeters squared. Now let's look at these 2 faces. They are also opposite faces, so the area of this one will be 32 centimeters squared. Let's look at the last one, 24 and a blank. Because they both are opposite faces, this will be the same, 24 centimeters squared. So now we've solved all the missing side lengths and the areas. Question 11. The graph shows Sophia's journey from Santiago to Rancagua. The graph shows the distance from Santiago in kilometers and then the time. Chen travels the reverse journey from Rancagua to Santiago. He leaves Rancagua at 2:30 p.m. and arrives at Santiago at 5:15 p.m. He travels at a constant speed. Draw a line on the graph to show Chen's journey. So first let's see the starting time. It's at 2:30. And let's see the ending time, 5:15. And the distance is 90 kilometers, as that's the ending for Sophia's journey. So we start at 2:30 p.m., 90 kilometers, and then draw a straight line from here to the bottom. So write down the distance they were from Santiago when they passed each other. The B part. So let's see. Where did they intersect? 3:45 p.m. at 50 kilometers. So that's the answer. Question 12. Work out 2.55 multiplied by 3.6. So that'll be equal to 255 multiplied by 36 and divide by 1000. So let's multiply 255 and 36. That'll be so when you add these up, 9180. That'll be 9180 divided by 1000, which is equal to 9.18. 13. The exterior angle of a regular polygon is 72 degrees. Work out the number of sides of this polygon. So let's look at the polygon. So if the exterior is 72, The interior will be 180 minus exterior angle, which is 72, 108 degrees. The interior angle, when you multiply that by n, which is the number of sides, for the sum of the interior angles, so 108n will be equal to, there's a formula for the sum of interior angles, that is 180 into n minus 2, which is equal to, when you expand the bracket, 180n minus 360. Bring the 360 to the other side and 108n to the other side. 360 equals 180 minus 108 multiplied by n. So that'll be 72n. So n equals 360 by 72, which is equal to 5. So 5 sides. That's a pentagon, a regular pentagon. Question 14. One of these statements is wrong. Put a cross next to the statement that is wrong. First is 48 divided by 20, which is equal to 48 divided by 2 divided by 10. So that's correct because we have to go from left to right to do the calculations. 48 divided by 20 is 2.4. 48 divided by 2 is 24. Divide that by 10, 2.4. Yeah. Next, 48 divided by 20 equals 48 into 5 divided by 100. Let's see. So 48 divided by 20 is 2.4. And 48 into 5 is 240. Divide by 100, 2.4. Correct. 48 divided by 20 equals 20 by 48. This will be 2.4. And 20 by 48 will be less than 1, which is obviously not equal to 2.4. So that's the cross. Let's just see the last one. 48 divided by 20 equals 48 divided by 4 into 5. So you have to do the brackets first. That'll be 20. So 48 divided by 20 is 2.4 on both sides. Therefore, the third statement is wrong. Question 15. Work out 3 minus 2 by 3 multiplied by 1 minus 5 by 7. So 3 can be written as 9 by 3. And subtract 2 by 3. Multiplied by 1 can be written as 7 by 7 and minus 5 by 7. That will be equal to 7 by 3 multiplied by 2 by 7. Let's cancel that out. So that will be equal to 2 by 3. That's the answer. Question 16. Complete the table by ticking the correct column for each measurement. 1400 milliliters. That will be 1.4 liters. So that's more than 1 liter. Number 2, 1000 centimeters cubed. There's a fact that 1000 centimeters cubed is equal to 1 liter. We need to remember that. Next is 100,000 millimeters cubed. So 1000 centimeters cubed is equal to how much millimeters cubed? 1000 multiplied by 10 3 times. So 1 million millimeters cubed. So that's equal to 1 liter. This is 100,000, so it's less than 1 liter. 17a. The diagram shows the plan and elevations for a 3D shape. Tick which 3D shape the plan and elevations show. So let's look at the top part. The width is 2 units. Then there's a length of 3 units and then a length of 2 units for the length. So now let's look at the side elevation. It's 2 units wide and then the height is 3 units and then 1 unit on the bottom. Next is the front elevation. That will be 4 units tall. Here it's 1 unit tall. Then that'll be 3 units tall, 5 units, and that's 3 units. And this is also 2 units. So we've got the lengths for the plan. So let's see which one matches all 3 of them. According to me, it is this one, because if you look at the front, it looks like this. And then there's this shape over here. And then when you look from the side, it's this shape over here, but then this part is not seen. So next, when we look from the top, which is the plan, we can see this and this. So this will be shown upwards, but it'll just look upwards, but it'll just look like it's up, but then it's actually down here. That's why the line. So this is the one. B. Here's a drawing of a cuboid measuring 2 centimeters by 4 centimeters by 6 centimeters. A different cuboid measures 2 centimeters by 3 centimeters by 5 centimeters. Draw this cuboid on the isometric paper below. First, let's draw the first rectangle. Over here, in the example cuboid, it is this one, which is 2 by 4. Over here, let's make it 2 by 3. So let's start drawing. That'll be 2. Go downwards. That's 2 by 3. Now we draw the side rectangle. Over there it is 2 by 6. Over here we need it to be 2 by 5. Make it 5 units to the right, downwards, and connect. Now we look at this length over here. Let's just draw that. That'll be same length, 5 units. And then let's connect this. So this is how it'll look. And now let's draw the inside. Let's draw dotted lines for that. And now remember, we have to stop at the 2 unit place, because the dotted line will go this way and intersect there. And also you need to keep it 2 units height. So there you have it. There's the cuboid. Question 18. A shape is made from 6 cubes. Write down the number of planes of symmetry for this shape. In one of my previous videos, I explained what planes of symmetry means, but let's take a quick recap at it. In a 2D shape, let's take a rectangle. There are 2 lines of symmetry which go like this. These are lines of symmetry. Over here is 3D shape. So let's say we draw a line here. That'll make a line of symmetry, but then we need to make it go this way as well. And then it'll go a little inside. We can't see the inside part, but then it'll go like that. So that's a plane symmetry. And this is actually the first plane of symmetry. And yeah, there is one more plane of symmetry. Can you find it? So the plane of symmetry number 2 goes like this, downwards. So it intersects the middle of this, and then it comes right back up. That's the second plane of symmetry. It doesn't look perfect, but then you get the idea because you can't see some parts of it. But that's the second plane of symmetry. So there are 2 planes of symmetry. Question 19. Calculate A. 34 into 19 plus 36 into 19 by 35. So if you multiply 34 into 19 and 36 into 19, we don't have to do that. We can make it as one expression. So that'll be 70 multiplied by 19, because 34 plus 36 is 70. And divide by 35. Well, 70 by 35 will be 2. So 2 into 19, which is 38. That's all. That's the answer. And what we're doing is we're just making it simpler to do. Number 2. 54 squared divided by 27. Just take this as 54 multiplied by 54 divided by 27. Now we can cancel out one of the 54s and the 27. And that'll be 108. That's the answer. Question 20. The graph shows the line with equation 2y equals 3x minus 1. A. Find the gradient of this line. So first let's make this into a y equals mx plus c. Right now we're having it as 2y. We don't want the 2. So let's simplify that expression. Y will be equal to 3x minus 1 the whole by 2. 3x by 2 is 1.5, so 1.5x. And then minus 1 by 2. Y equals mx plus c, and m is the gradient. So this is the answer, 1.5. B. Draw the line x plus 2y equals 7 on the grid. We don't have any values for it, so how do we do it? The answer is simple. We create our values. So let's take an x value and y value. So let's take the x values to be intervals of 2. Let's make it from minus 3, minus 1, 1, 3, 5, and 7. These are the values we're taking. So let's write them down. Now we need to do x plus 2y equals 7. So if x equals minus 3 plus 2y equals 7, 2y equals 7 plus 3, which is equal to 10, y equals 10 by 2, which is equal to 5. You can work it out if you want. Next, when x equals minus 1, 2y will be equal to 8, and at the end y equals 4. Do it when x equals 1, y equals 3. Next will be 2, 1, x equals 7, y equals 0. So these are the values. Now we just plot them down. So let's see the first point. X equals minus 3 and y equals 5. Let's plot that down right there. Next, x equals minus 1, y equals 4. We can plot that over here. Now we need to plot x equals 1 and y equals 3. That'll be over here. And then we continue plotting the points 3, 2, 5, 1, and 7, 0. And now 3, 2 here, 5, 1, and 7, 0. Now we just connect the points. So this is the line x plus 2y equals 7. C. Use your answer from part B to solve the simultaneous equations 2y equals 3x minus 1 and x plus 2y equals 7. So when you solve simultaneous equations using graphs, we need to see the intersecting point of both the lines. The blue line is x plus 2y equals 7, so the other line is 2y equals 3x minus 1. Now let's look at which point is the intersection point. Right there. The coordinates of this point are x equals 2 and y equals 2.5. So we'll just write that down. X equals 2, y equals 2.5. 21. A restaurant manager records the time in minutes that customers wait for their food to be served. The back-to-back stem and leaf diagram shows the results for customers eating at lunchtime and in the evening. So key is 2, 3, 1. Represents 32 minutes at lunchtime and 31 minutes in the evening. So the middle is always the tens digit. In this case, the column here. And then these are the ones digits. Well, you might ask, how can there be like so many one digits? There are many different customers, so different timings are there. So first, let's see. Some summary information about these times is shown in the table over here. A. Complete the table. So the median time in minutes for lunchtime. How many values are there in lunchtime? Count them down. 3 in this row, 7 in this row, 5 in this row, 1 here. 16 values. So that means the middle two, which are the 8th and 9th values, will make the median. 1, 2, 3, 4, 5, 6, 7, 8. 6, 9, 8. Remember, there's a 1 here, so that's the tens digit. 16 and 18. 16 plus 18 by 2 will be equal to 34 by 2, which is equal to 17. That's the median. Now we see the range for the evening time. This is quite straightforward because range is equal to the largest number minus the smallest number. That'll be 41 minus 9. 41 minus 9 is 32. So that's the answer. B. Tick to show when waiting times were generally longer. Over here we can see that the median time in the evening is longer than lunchtime. So in the evening, the waiting times were generally longer. Explain how you can tell from the values in your table. So as I just said, the median time for the evening is higher than that of lunchtime. C. Tick to show when waiting times are more spread out. Let's see the table again. So now we need to look at the range. 32 is higher, so that's more spread out. Let's tick in the evening because 32 is in the evening. Explain how you can tell from the values in your table. Quite straightforward. As I said, if the values range is higher, then the values were more spread out. So let's write this. The higher range is in the evening. Question 22. Hassan is investigating how long it takes people to travel to work. He designs a data collection sheet. The first column is shown here. This one. Write the missing values so that all intervals have equal width. There are 4 rows and it's 0 to 60. So 60 minus 0 by 4. 60 by 4 is 15. So the width is 15. So let's fill in everything. Yeah, that's all. 23. Write the correct fraction in the box. Dash into 3 by 4 equals 1 by 2 plus 1 by 6. So 1 by 2 plus 1 by 6 will be equal to 3 by 6 plus 1 by 6, which is 4 by 6, or 2 by 3. So something multiplied by 3 by 4 is 2 by 3. So that something is 2 by 3 divided by 3 by 4, which is equal to 2 by 3 multiplied by 4 by 3. So that'll make 8 by 9. 8 by 9. Question 24. A diagram shows a triangle drawn on a grid. Enlarge the triangle with scale factor 3 and center 5, 4. Let's look at this triangle. The center of enlargement is 5, 4, which is this point right there. Now let's look at the lengths of the triangle. This is 2 units. This is 3 units. And this is also 3 units. So we need to multiply that by 3, each of them. And that'll be 9. That'll be 9. The sides we need are 6 units, 9 units, and 9 units. Now let's look at the distance of the points from the center. So this one is 2 units. This is 1 unit. And this is also 2 units. So we need to multiply this by 3. So that'll make 3 over here, 6 over here, and another 6 over here. So 6 distance from the center point, just 5, 4. So now let's start drawing the triangle. So first we see what point is 6 away in this direction from 5, 4. So that will be 5 comma 10 up here. That's 1 point. Then 3 away in this direction from 5 comma 4, and that will be 2 comma 4. Next, we need 6 away from the point in this direction. So that will be 11 comma 1. Now let's join the points together. First 5 comma 10 and 2 comma 4. Join. 5 comma 10 and 11 comma 1. Join. 2 comma 4 and 11 comma 1. Join. So this is the triangle, the finished triangle after enlarging it. And now for a clear view of it, let me erase all the points which I've drawn. So this is the triangle. And that's the end of the paper. So hope you enjoyed, hope you liked my video. See you in my next video. Thank you. Bye.